Okay, what are we looking at? Somebody want to introduce what this is?
This is a Williams 30-inch wide disc screen. We're going to demonstrate it doing a scalping job on coal. This is a 30-inch wide Williams rotary disc screen. It's presently set up to make a capacity check on scalping coal. The screen has an IFO of 7/8 inch and a slot length of 3 1/4 inch, which should give us a throughs product of approximately 3/4 inch by 0, with the plus 3/4 inch coming into the oversized pit. We've loaded the conveyor belt to feed the screen at a rate of 50 tons per hour.
Okay, you want to turn on the screen. All right, Joe, I want you to hold that microphone over by there. Okay, turn on your conveyor.
By looking at the oversized discharge, these pieces are obviously larger than the 3/4 inch anticipated, and they did report to the oversize. Looking at the remainder of the coal in the oversize, there would be less than 1/2 pound of undersize reporting with the oversize, which is exceptionally good efficiency on screening.
Okay, would you please show me the underside? That's all right, you just reach in.
I can get in there now. The undersized product is obviously all minus 3/4 of an inch. I don't observe any oversize whatsoever.
All right, thank you. That's right. All right, Joe, start again.
This is a 30-inch wide Williams rotary disc screen. We're going to demonstrate how it can scalp the fine material out of the coarse material with a feed of typical furniture factory wood waste. The undersized material will be acceptable for firing in the furnace stoker. The oversized material will report to the oversized bin and eventually to a wood hog to convert it into small-sized wood fuel.
Other than a dusting pump. I need the mic to talk about it.
This is the undersized material which passed through the rotary disc screen. in order that it can bypass the hog. This is the size particle that the following hog would make, so that the undersize would match the oversize after passing through the hog. The oversized material is absolutely clean of the sawdust. Okay. This is a 30-inch wide Williams disc screen. We're set up presently to demonstrate it scalping wood bark and waste wood to prepare it for boiler fuel. The fine material will pass through the 7/8 inch IFO openings with a 3 1/4 inch slot length, which will be suitable for boiler fuel. Any oversized pieces of bark or wood waste will pass over the top of the screen and go into the oversized reject chute, which ordinarily would pass to a wood hog to reduce the size similar to that which went through the screen and be suitable for fuel.
Okay, stay there with Mike, please.
Damn thing does everything it's supposed to do.
Lift it up like you had before, that was good.
This is the oversized material which was too large to pass through the screen, which would be directed to a wood hog to make it smaller and to be suitable for fuel in the boiler. There's practically no fine material in the coarse side, which indicates that the screen made a very efficient size separation.
Okay, thank you.
Here's a look at the material that went through the screen, which does not contain any coarse particles, and it's been very well conditioned as fuel for the boiler.
Okay, thank you.
This is the Williams 30-inch wide rotary disc screen. It's going to be demonstrated on screening the fines out of a coarse shredded waste paper material. The IFO setting of the disc screen is 7/8 of an inch with a 3 1/4 inch slot, and will make an approximate separation at about 1 inch, the -1 inch going through and the +1 inch going to the oversized bin. This is the oversized material, which is obviously +1 inch size. And there's no trace of any fine material smaller than 1 inch in this oversized product.
Okay, you want to pull out the fine?
Here's the undersize, which passed through the screen, which is nominal 1 inch and smaller. There's no oversize contained in this. There's no long streamers contained in it. It was a very uniform, efficient separation of the fines from the coarse.
Okay, thank you. They're trying to make you another copy.
Well, we don't want to put the commercial in here, though, do we, about GE?
No.
We're going to simulate a disc screen operation feeding material which has passed through 2.5-inch round holes in a trommel screen. What went into the trommel had passed through a flail mill. The 2.5-inch minus fraction from the trommel will be fed to the disc screen, which is intended to make a cut at 1 1/4 inch to put the plus 1 1/4 overs into this container, which will be clean combustible material. The through material, which is minus 1 1/4 inch, will go into the lower container, and we expect that to be mostly non-combustible material, which is glass, grit, stone, and so forth.
Okay, you want to start the screen, please? You want to see the material by itself? Okay, we do that too. Bring it around here. Material we're looking for.
This is a sample of the feed material which is going to be fed to the screen.
What's the weight?
It's 3.1 pounds per cubic foot at 30% moisture.
Okay, go ahead. Let's feed it. See how fast to feed?
Yes, we're going to feed it at the rate of 2,400 pounds an hour to our 30-inch wide 5-roll disc screen.
Okay, go ahead. Ready?
25 seconds, right on it. This is the oversized material separated by the disc screen, which is essentially 2 1/2 inches and larger. I beg your pardon, 1 1/4 inches and larger.
Okay. Pull it out. Now, if you would, turn it sideways. When you turn it sideways.
This is the front, and that's the back.
This is the front.
This is front end up here, that's the back end. That's the feed in, this is the discharge in.
This is the throughs material from the disc screen, which apparently is all minus 1 1/4 inch, and it will contain most of the non-combustible material, such as bits of glass.
Joe, would you say that that's pretty evenly loaded? Is there more in one location than others?
The predominant discharge area on the screen was approximately in the center section, and you can see it tapered off toward the discharge end, indicating that it was a good capacity rate for good efficiency. We can notice that even the bottoms of the bottles went through the throughs because they go on edge and get through the slot length, which is 3 1/4 inch.
Okay, hold things a little lower because you're not, yeah, that's it right there.
Now that is larger than the 1 1/4 cut, except for the thickness, which the slot length permitted it to pass, which is what we wanted it to do, and put the non-combustibles in the undersize. Find any rocks?
Found a rock here. I found a piece of
Here's a piece of rock or grit, which was also intended to report to the undersize.
Okay, now what we need to do, okay, is it rolling down there?
Ready to turn her on?
All right, go ahead, turn it on. All right, go ahead.
Okay, 19 seconds.
A little faster.
19. We had 25 last time. There's definitely undersize in here.
Does it look different on the bottom? He was feeding it slower at the beginning.
Okay, can we pull the bottom section in?
definitely looking finer.
There's less there, right?
It looks like it.
Definitely far less material.
That's because we cut it faster.
Yeah.
This feed material is the oversized product from a previous run over this same screen. It's essentially plus 1 1/4 inch, although it contains at the same time considerable undersize, which did not pass the screen on the first introduction to the screen. Our simulation now is having a second disc screen or following the first disc screen, and to see if we can get improved efficiency by running it over 5 additional rolls.
Okay, you want to start it?
Ready?
I got 14 seconds.
I got 16.
Okay, call it 15.
It's getting there.
There's noticeably less undersize in this oversized product.
There's a piece.
Okay. Let's pull out the fine, please.
It shows a pretty good distribution of screening the greater portion on the first 3 rolls with a good taper off toward the 5th roll.
Get the little piece of the glass. Stick come through there.
There was no doubt there was a high
Yeah.
percentage of fine.
Yes, this indicates the fine material that was carried over with the coarse on the first pass across the screen. Now we have hardly any visible oversized plus 1 1/4 material in the fine fraction. I think we have gone a ways toward proving that a 2-stage disc screen should be quite efficient.
Okay, next.
This is a Williams rotary disc screen. It's 30 inches wide by 7 shafts across the length. We have a 4-inch IFO dimension between the adjacent discs. Today we're going to process waste gypsum board that was off of an old storage pile from the Stony Point plant, Stony Point, New York plant of USG Company. The feed rate will be approximately 2 tons per hour. We're going to separate the trash from the relatively clean gypsum. The trash materials will come over the top of the disc, report here, and the undersized material will fall through the interface openings onto some conveying mechanism. Than 4-inch material which has passed through the disc screen and which will proceed on to the process.
Let me get a close-up shot of that.
You notice it's quite high moisture, damp and sticky, but the screen had no problems with blinding or accumulation of sticky material. Intermeshing rotary disc causes self-cleaning action. Now we can view over here the oversized, larger than 4-inch material which travel over the top of the screen, including a piece of angle iron, 2x4 wood, chunks of wood, and these are pieces of raw, oversized rock, which should not pass through the following process. None of these pieces of oversized rock, wood, or metal jam the screen. If somehow they would jam the screen will automatically stop, reverts itself to clear the jam, then automatically proceed in the forward screening direction once more.